Let's talk about these. Let's talk about solving the domain algebraically for a bunch of circumstances. Let's talk about the first one. You have a polynomial here. Notice here you have variables. The exponents are numbers, not letters. Here I have a quadratic, and here I have a linear. How do you find the domain? Well, you'll recognize that if you draw a quick sketch of these, use a red pen. Remember, domain is from yesterday's lesson going left to right. Those are all your x values. So if you go from arrow to an arrow, it's going to be all real numbers. The domain of all real numbers, its symbol is the r. And then in interval notation we learned yesterday, it goes from negative infinity to positive infinity. And that should be the same thing for a linear. Negative slope, right? Going from left to right, you have arrow to arrow. So anytime you see the arrow and arrow, it's always going to be negative infinity to positive infinity, or all real numbers. Let's talk about a fraction or a rational function. When you see a fraction, you have something over something. This is rational function, so we're going to be talking about this very soon. And so I want you guys to have information on it. Basically, to find the domain, you set the denominator not equal to 0. What is the denominator? That is the down part of the fraction, right? The bottom. Okay, so basically you're setting each of those not equal to 0. Not equal to 0, but equals with a slash through it. Okay, because if I put a number in there such as 0, you can't do 4 divided by 0, right? We said that was bad. Okay, number 3. Square root only. So let's just say we're going to focus on these. We have the square root there. How do you find the domain? You set the radicand greater than or equal to 0. The radicand is the number underneath, inside there. Okay. Number 4, let's just say you have a square root in the denominator or in the bottom of the fraction. So you're going to set the radicand here greater than or greater than 0. And the reason why you put it greater than 0 is because if you make it equal to 0, if you did like 3 minus 3, you would get 0, square root of 0 is 0, and then this would all become undefined. That's divided by 0 would be bad, so it has to be bigger than 0. And then the last one basically has all the combinations of them. Let's just say you have a rational function here, right? You have a fraction. You're going to set the denominator not equal to 0. So this is the denominator, setting all of that. There's your denominator, not equal to 0. You're also making the radicand in the numerator greater than or equal to 0. That's just a combination of the one above that we had. And then you take the intersection of both those values. So I would star this page, put a tab on it, and you can go back to it when we go over these.